Okay, so this is Jefferson's method from example 2.3, beginning on page 96 of the textbook. What I've done up until now is the exact same thing as Hamilton's method and Lowndes' method. And that means that I first copied over the population and the counties that they gave me. I read from the question that they're dividing 37 seats. So I added up the total population, right? Divided the total population by 37, and I got the natural divisor. And then I divided each of the populations by the natural divisor to get the natural quota. We saw, though, that when we see that when we have the initial allocation, the total number of seats apportioned, it's 12:30 in the morning, is 35, and not 37. So this is where Jefferson's method comes in. So Jefferson says, okay, well, we want it to be 37. So one way of doing that would be to change the natural quota. Well, if we change a natural quota, it wouldn't be natural anymore, so let's call it a modified quota. So over here, I copied over the natural quota of 2,609.19, and I just copied it over here. So over here, I'm just going to copy it over again. So now the question would become, what would we change the modified quota to? Well, we're going to try a few different things, and we're going to see what works. But the overall strategy is going to basically say, okay, the largest ones are going to wind up getting one more seat probably somehow, right? So we're going to take the population of let's say Cumberland, because it has the largest of the decimals. See how it has 0.75, the other one has 0.66, and the other one has 0.448, and the other two are just 0.0 whatever. So this is 0.75. So it's gonna add something. So we're going to divide it we're going to divide it by the initial allocation plus 1. The reason for that is a little bit complicated, but let's not go into it. Let's just actually do it. So the initial allocation for Cumberland was 9. Let's change it to 10 and divide by that. So we would get a modified quota of 2545, exactly. Now, we're going to treat it as if it's the natural quota, and we're going to find a new modified quota. I'm sorry, this is called the modified divisor. This is going to be the column of the modified quotas. I apologize for misspeaking. Okay, so we're going to take the population and divide it by the quota, by the divisor, I'm sorry, and we get 10, which is what we divided by. We're going to take the population divided by the divisor. We're going to take the population divided by the divisor. Take the population divided by the divisor. And take the population divided by the divisor. I made a mistake. Okay. Now, let's call this, let's say, a modified allocation. And it's going to be like the initial allocation, but it's going to be, it's just not the first time, it's the second time now. So we can actually just call it allocation. Sorry. Maybe I'll fix this video later if I'm not bored. Okay, if I am bored. So we're just going to round down. So 3.75 rounds down to 3. 11.77 rounds down to 11. 1 point whatever rounds down to 1. And 11 point whatever rounds down to 11. And then we take the total. So we just add these all up. And you get 36. So we're closer to 37. Now the number that we need is, instead of 37 minus 35, we need 37 minus 36, which is just 1. So let's do another modified quota. So this time, instead of taking the largest of the decimals, let's take the second largest of the decimals. So here we have 0.66, right? So this time we're going to divide the population for Hancock by the initial allocation that Hancock got, given the natural quota. So let's take the population, and we're gonna add 1 to the initial allocation. So instead of dividing it by 3, right, Let's divide it by 4. And we get 2387.25. Now let's treat it like it's a natural divisor, right? Let's just divide all the populations by the modified quota. And we'll get this, and then this is getting divided by this. You can pause this video and do this math yourself. Because I'm using an advanced calculator, I can cheat. And I'm just going to do division quickly like that. And then I'm going to have another allocation. So, oops. Yeah, I can actually write this here. Okay, so we're going to round down like we always do. Yeah, we'll wind up with 10 over here, and then 4, and then 12, and then 1, and then 12. And if we add these all up, again, you can pause this and do it yourself. But I'm going to take a little bit of a shortcut. We get 39. 39 is more than 37, or let's actually go back. Let's make this smaller. Actually, decisions. Let's hide this. Okay, so if we take the number that we would have left, right, we would, let's say, put it over the 39, and we would see that we have -2. So we want that number to be 0, so let's try another modified quota. This time, though, let's try using the population for Lincoln. So Lincoln's population is 29,962. So let's copy that. And what was their initial allocation? 11. Let's make it 12 and see what happens. So we have a modified divisor of 2,496.83. Now let's treat it like we treated all of the others, and let's take the population and divide it by the modified quota. Then let's do that again. And then again, I'm just getting a little bit lazy. I'm just going to do the same thing every single time. Pause the video and practice your division if you feel like it. I kind of find it boring. And then we're going to have another allocation where we round down. So this rounds down to 10, this rounds down to 3, rounds to 12, rounds to 1, rounds to 11. And if we add them all up, I'm going to do it slowly because I think it's going to be the last time we have to do this. Could be wrong. You get 37. So now when we say the number left to be added is 37 minus 37, we get 0. And this is not just an allocation, it becomes our final allocation according to Jefferson. So it took us a few tries to get the correct modified quota, and the correct modified divisor. But in the end, we got it, and we didn't use any thinking. We just kept on trying multiple times. I'm going to do another example in another video.